Okay, so for number 19, you have sine negative x over cosine negative x. Now, one thing we can do here, a lot of times we'd like to get rid of those negatives inside if we can. So there's a couple of things I could do here. For instance, I know that sine over cosine is tangent, right? So whatever the angle is, even if since they both have the argument of negative x, I could just put tangent of negative x down, right? This one's almost too fast to work. Now, do you remember that on our functions, we have even functions and we have odd functions? And do you remember the even ones in trig are just cosine and then its reciprocal is secant. You're going to need to know this today, okay? Because there's one problem on it. And what that means is if you get like the cosine of negative x, it's equal to the cosine of x. So you can just replace, if you ever see a cosine of negative x, you could just replace it with cosine of x, okay? Now, and secant works the same way. But do you remember that on the odd functions, what happens if I have, like, for instance, sine of negative x? That is equal to the negative of the positive value. Like if I've got an angle and I'm trying to find the sine of the negative of that angle, it's equal to, find the sine of the angle, like 45 degrees. Let's say this was sine of negative 45 degrees. What I could do is say that's the same thing as the sine of 45 degrees and then just slap a negative in front of it. That's how those even and odd functions work. And just a reminder, not that you need to know this for the quiz today, but how you know if something is even or odd. If it's even, what it is it's symmetric about the y-axis, okay? Just reminding you this because this stuff's coming up in calculus, and I'm thinking it'd be good for those of you who are going to take calculus to kind of see, kind of hear it and be reminded of some stuff just because we just covered it this week in calculus. Symmetric about the y-axis. So things that are even functions are things that if I fold it over the y-axis, it's going to match up. The reason cosine is symmetric about the y-axis, if you think about it, it starts like this and it goes down and it goes like this. Do you see if I fold it over the y-axis it would match up? But sine's not that way. So this is kind of good for a little mini lesson here. Sine does this, and if I fold that over the y-axis, it's not matching up. And so if I don't know what the graph looks like and I'm trying to decide if something's even or odd, I would look in the I would put it on the graphing calculator and just check a graph of it. That's the fast way. It's not like, because in calculus what we do is we get these weird expressions. You're like, how am I supposed to know if it's even or odd? And really the only way the book even tells you to know if it's even or odd is to look at a graph, which that's what your graphing calculators are great for, right? You don't have to go plot a bunch of points and then see. You can quickly check it. Okay, so y'all don't need to know all that for today, but it's just kind of like another little mini reminder of what does even and odd mean, because it doesn't go away. We have talked about it a little bit in this section. Now, tangent of negative x, that is going to be an odd function because it's not cosine or secant, right? Anything that's not cosine or its reciprocal is odd in trig, okay? So, and you can see that if you looked, it's not going to fold right over itself over the y-axis. That's how you could know it if you didn't know it. So if you remember the odd things, how they work is tangent of negative x is equal to the negative of tangent x. Okay? For you. Number 49, we got the cotangent of negative theta over cosecant is equal to, let's see, it's theta. So easy to want to leave those things off. You're just like, oh, I know what I mean. I don't have to put the theta on it, but better here because it's got a negative on one and the other one doesn't. Okay, if I were doing this, I would probably get rid of that since the arguments don't match. I've got a negative theta on one, right? And I've got a theta on the other. So if I'm just starting with my left-hand side here, I probably want to get rid of that negative off that top one, and I can do it really easily because is cotangent even or odd? Odd. It's only even if it's cosine, right? Okay. So it's only odd if it's cosine or the reciprocal of cosine is secant. So what that means is that top part is equal to negative cotangent theta. I can just get rid of it that fast, okay? Those little rules help me get rid of these weird looking things because we don't want to carry along and have to think about them. Okay, so now I've got cosecant theta. What do you think I would do next? Yeah, right. Anytime you can, when you've got something that's kind of, there's no squares here, there's not really much that we can do. Yeah, we rewrite them as sine and cosine. There's going to be one on your quiz today where that's where you're going to want to do and so we're going to go do that now. Now, cotangent, how would I write that in terms of sine and cosine? Cosine over sine. Tangent is sine over cosine, so cotangent is cosine over sine. Good. Okay. Now I got my big fraction bar here. What about cosecant? What is cosecant? 1 over sine. It's the reciprocal sine. Very good. So I'm going to write that as 1 over sine theta. And now I got a complex fraction. And do you remember that what you do in a complex fraction is you keep the numerator. And write it down. You change that fraction bar's division, so you change it to multiplication, right? And then what do you do with the denominator? Y'all remember? You flip it. Good. You take the reciprocal, you flip it. Okay, so it's going to be sine theta over 1. Let me just make a big fat bar since I messed up. Okay, and so now these cancel out, don't they? And I've got what I wanted. I've got it equal to negative cosine theta. And so there we've matched it up, haven't we?